Hello everyone, welcome to Mifratech. Today in this section we are going to study an important basic, like you can call an essential machine learning library, that is Numpy, numerical Python. So these are the concepts we are going to cover in this section. Let's first we are going to see what is Numpy, then what are the different features of Numpy, then what are the operations can be performed by using this Numpy library, and what are the different applications of Numpy. So let's start our discussion with what is a Numpy. As I told, it is a important fundamental package for any scientific computing in Python. So it is mainly built upon working in Python. So it is a numerical Python. So it will help us to handle a numerical data, do a data manipulation, and do mathematical operation on numbers. So it is mainly the numerical Python or Numpy package or a library which provides us a powerful n-dimensional array object. So by using this n-dimensional array, we can store the real-time values data, and we can do any number of manipulation data manipulation techniques or any operations we can perform and use for linear algebra and different mathematical operations we can do that. So it is also used in industry for array computing. So it mainly provides, as I told, n-dimensional array object as compared to the traditional Python list or Python array. This Numpy provided n-dimensional array is 50 times greater than the traditional Python list. So it is very faster computing like object, array object, which is provided by Numpy library. So what are the different features of Numpy? So as I told, it mainly provides a n-dimensional array object. Then it also provides us different types of inbuilt functions for mathematical operations. So we can also use this with like C or C++ for Fortran code. This works well with these programming languages also. So mainly it will provide us useful linear algebra, a Fourier transform, random number capabilities. So n number of mathematical operations, inbuilt functions we are going to get in this Numpy library. So let's see what are the different types of operations can be performed by using this Numpy library. So first we'll see how to create an array. As I told, it is an important thing. It is an object that is given by Numpy library, a powerful n-dimensional array. So let's see how to create an array in a Numpy library. So first we have to install a Numpy in your Python IDE or any IDE what you are using for this purpose. So we have to using like a pip install Numpy, or you can use in a condas or different command in a command prompt. First we have to install this Numpy. After installing, first thing is we have to load that library. So to load the command what we'll use is import a Numpy as np. Here the command what we are using to import a Numpy library is import Numpy as np. Here import Numpy as, up to that it is a we have to use the same exactly, but np is a user defined value. We can use instead of np a k, p or any name, anything you can use, any variable. So usually we'll use np only, so that this line is going to load the library. So after loading the library, we have to create array. So here we are creating array as a row. So we are creating array in a single row. So to create an array, the command what will use in the Numpy library is np.array of something in the bracket. So we have to provide some parameters in the bracket to create an array, so data. So the main command is np.array of some function we have to provide. So here I have provided np.array of a list of values 1 to 3 are given for this as a parameter. So that array what I am going to get, I am assigned a name as array underscore row. So when I am going to print this array underscore row, I am going to get a numerical Python array. So how to create this array as a row? This I told how to create array as a row. You can also create this array in a column. So to do that, it is same. np.array of will going to create array, but only while passing the parameter we have to pass it in a different like a syntax or a manner. So here I am passing each value. After each value I am giving a comma, means that will take us to the next line. So this 1 to 3 values I am going to like get it in a column. So if I print array underscore column, I am going to get this array value in the form of a column. So this is how we are going to create an array. So let's see how to create a matrix. As I told, matrix is a combination of both rows and columns. So let's see how to create this matrix using Numpy array, like a numerical Python library. So first we have to load library as usual, that is import a Numpy as np. Then after loading the library, we have to create an array matrix. So to create an array, the command is np.arrayof. Here I am giving a row value as like previous example 1 2 3. It will give us the first row. After, if I give a comma, it will take us to the next line. So 4 5 6 will be printed, taken to next line. So this is how a matrix will be created, that is np.array of these values. So that matrix what we created will given stored in a variable matrix. If I print that print of matrix, I am going to get output as in the form of a matrix, like 1 2 3 in the first row, and 4 5 6 in the second row. So it will be in the form of a 2 cross 3 matrix, that is a 2 rows or 3 columns matrix. So let's see how to select items, or like how we are going to access element that is stored in an array, or we are going to print those arrays. So first we have to load the library, that is import numpy as np. Similarly, we have to create an array as a row, as I mentioned in the previous example. So array is equal to np.array of, if I pass 7 8 9 2 is the least value, it will be created as an array. After creating array, when we have to access, I have to print this 9 value, or when I have to access this line value, I can do that just by mentioning the location, that is the indexing value of that element in the array. So just if I do print of array of 2, here indexing will be like 0 1 2 3. Now minus, it will be in the reverse, -1 -2 -1 -2 -3 -4. If I just mention 0 means I am going to get a value output as 7. If I do array of 1 means I am going to get 8. Similar way, if you want, here in this example I want 9 value, so I am going to print array of 2, so our output I am going to get as 9. This is how we are going to access stored array elements. So let's see how to describing a matrix. Describing a matrix means how to print the shape of a matrix, and what are the total number of elements present in a matrix, or what is the size of the matrix, or what is the dimensionality of the matrix. So that can be easily done using some inbuilt functions. So first we have to load the library as usual. After loading the library, here we created a matrix that is as same as the previous example, like matrix is equal to np.array of it is a 2 cross 3 matrix I have created using this np.array. After creating the matrix, when we want to know number of rows and columns, that is the shape of a matrix, just we have to use, that is matrix name dot shape. So using just this dot shape of function matrix dot shape, I am going to get the shape of a matrix. The output I will get as 2 rows. In this matrix what I have created, it is a 2 rows and 3 columns matrix. I will get output as 2 3 or a 2 cross 3. A similar way, to get or to know print what are the total number of elements present in a size, I have to use the inbuilt method, that is matrix dot size. So this command matrix dot size gives the total number of elements present in this matrix. So to know the dimensionality of the, like it is a 2 dimensional, 1 dimensional, to know the dimensionality of the matrix, we should use matrix dot ndim. So using this command we can get to know the dimensionality of the matrix. So we can also find the maximum and minimum values in a matrix or array. So that can be done by using a inbuilt method. Let's see how can that be done. So first we have to import a library, that is import a numpy as np. After importing the loading the library, have to create a matrix as like previous, but in this example I have created a 3 cross 3 matrix, that is it has 3 rows and 3 columns. After creating the matrix using np.array, I am going to print the matrix. Then in this matrix I want what is the maximum element. When I want to print a maximum element, the inbuilt method what I am going to use is just a np.max of matrix. So in this matrix, what is the maximum value I want? This syntax is very simple. Just using np.max of that matrix name, if I give what the maximum value in this matrix is 9, so I am going to get output as 9. Similarly, when you want to print a minimum element, we should use print of np.minimum of matrix. So just using np.min of matrix, I am going to get the minimum value, that is 1 as the output. So we can also find the maximum and minimum value in each column. So we can just mentioning np.maximum matrix in the second parameter. If I mention axis is equal to 0, I am going to get the maximum value in each column 0. when I want to find the maximum element in each row, I can change this axis value to 1. I'm going to get the maximum element in each row. So this is how we can find maximum and minimum values in a matrix or in a particular row or a column. So let's see how to calculate average, variance and standardization. So these mathematical operations can be done manually, but it takes a lot of time. So these can be done very easily for a like enormous amount of data. When we have huge data, we cannot do it manually. So that occupies a lot of memory and takes a lot of time. So for the tedious stuff, we can do it easily by using this Numpy library inbuilt function. So let's see how that can be done. So first we have to load the library. First we load a library as import Numpy as np. After loading the library, we have to create a matrix. So matrix is equal to np.array of a 3 cross 3 matrix I have created it. Then we'll printed the matrix. So let's see how to find the mean or average of a matrix. That just by using this command, that is np.mean of matrix. This value is this command is going to give us the what is the mean of this matrix, that is np.mean of matrix. So how to find the standard deviation? To find the standard deviation, we should just use np.std. So .std of matrix. So this command is going to give us the standard deviation of this matrix. So variance. So to calculate variance, just we have to use np.var where np.var of matrix. If we use this command, we are going to get the output as a variance of this matrix. So let's see how to reshape the array. So like once the arrays has been created, but in a like if we consider in a traditional manner in a Python list, once the arrays has been already defined, we cannot reshape or we cannot input the size of the arrays. But in Numpy arrays, the arrays provided by the Numpy library, we can reshape those arrays. How? Let's see how that can be done. So first we have to import the library as usual. After importing the library, we have to create a matrix. So after creating this, here a 3 cross 3 matrix has been created using np.array of. So after creating the matrix, we are going to, this is a 3 cross 3 matrix as I told. So how this 3 cross 3 matrix again we are going to reshape. So using that matrix dot reshape of command. So this function dot reshape of function, if we use this, is going to reshape our original matrix however we want. Here matrix dot reshape of 9 cross 9 comma 1. So this exact command is going to give output as we are going to create this 3 cross 3 matrix as a 9 cross 1. We are going to get a 9 rows and 1 column. So in a single column we are going to get from 1 to 9 values. That is how we are going to reshape the matrix. So we can also reshape the matrix in this manner, and we can also retain a one-dimensional array of length. So if you want in a row or in a column, we can do it by reshaping this. So we can also convert any matrix into one-dimensional array just by using matrix dot flatten. Dat flatten of function is a method which is going to convert any matrix into one-dimensional array. So by using this, we can convert 3 cross 3 matrix into one-dimensional array, that is matrix dot flatten. So let's see what is a transposing of a vector or a matrix. As we know, manually transposing is nothing but just changing our row values into columns and columns value to rows. That is what a transpose means. So that can be done manually, but we have inbuilt function for that also in a Numpy library. First we have to load the library, like import Numpy as np, then we have to create a matrix. After creating the matrix using np.array of function, we have to print the matrix. So the printed matrix will have rows and columns like this, like 1 2 3 and in one row, and then 4 5 6 in one row. Another row we have 7 8 9. So there is a 3 cross 3 matrix. When I do matrix dot t, this command will going to do the transpose of this already have stored matrix. So matrix dot capital T, this command is going if I do, we are going to get transpose of a matrix. That is nothing but in 1 2 3 we have in a row. In the next step we are going to get what are the values will be present in a single row, like 1 2 3. We are going to get those values in a column, and what are the other values present in a columns, we are going to get that in a rows. So that is how a transpose of a matrix will work. So we can also find the determinant and rank of a matrix. So finding determinant rank will takes a lot of time when we are going to do manually. So we have inbuilt methods or functions for to do those jobs also in Numpy library. So how to do that? First we have to import Numpy as NP. Then after that we have to create matrix, that is using np.array function. Here also in this example we taken same a 3x3 matrix. After creating a matrix, we find out how to find the determinant. So to find the determinant we should use np.linalg.det of matrix. Is nothing but in a numerical Python, determinant is a linear algebra function, so we should use it is present inside this package. So np.linearalgebra.det means determinant. So np.linearalgebra.determinant of matrix, if I do, I am going to get output as a determinant of this matrix. Similarly, we can also calculate the rank of a matrix. That is, similarly I have to use np.linearalgebra.matrix underscore rank. By just using matrix underscore rank of this command, rank of input, if I give which matrix rank I want, I am going to get rank of a matrix as output. So we can also calculate the diagonal of a matrix. To do that, first we have to import Numpy as NP, then we are going to create matrix as usual. Then after creating the matrix, when we want to print a matrix like diagonal of a matrix, if we can use only a single command, that is matrix.diagonal. If I just print of matrix.diagonal of, I am going to get the diagonal of this matrix. First, what is the diagonal? What I am going to get is a principal diagonal. We can also get the diagonal 1 above the principal diagonal and diagonal 1 below the principal diagonal. So to do that, we have these two commands, that is a same matrix.diagonal of function only. Just by passing the parameter offset is equal to 1, I am going to get a diagonal 1, that is 1 above the principal diagonal, and just by passing offset value is equal to -1, I am going to get a principal diagonal which is below the diagonal value which is below the principal diagonal. So we can also calculate trace of a matrix. So to do that, just first we have to import the library, then we are going to create a matrix using np.array. After creating the matrix, to find the trace, should just use a matrix dot trace of function. That matrix dot trace of function is going to give us the output as a trace of a matrix. So we can also find eigenvalues and eigenvectors. So these eigenvalues and eigenvectors has a very important importance in many machine learning algorithms and also in mathematics. So finding these eigenvalues and eigenvectors takes a lot of time and a huge number of calculation, and will take a lot of memory also. But by using a Numpy, we have inbuilt a function to calculate in a single command these eigenvalues and eigenvectors. Let's see how to do that. So import Numpy as library to load the library. After loading the library, again as usual we are creating a matrix using np.array of a 3x3 matrix has been created. Then after creating the matrix, we are going to calculate eigenvalues and eigenvectors of this matrix. So to do that, the command is we should use np dot same linear algebra package that eigenvalues. So eig is the eigenvalue. So this np dot lin algebra dot eig of matrix is going to give us the eigenvalues. Eigenvalues means it is going to give us both eigenvalues and eigenvectors. So to collect that, first is going to give eigenvalues, eigenvectors is equal to np dot lin algebra dot eig of matrix is going to give both eigenvalues and eigenvectors. So we are going to collect those using these variables eigenvalues and eigenvectors. So if we print individually eigenvalues and eigenvectors, we are going to get output as eigenvalues and eigenvectors. So eigenvalues usually indicate the what is the importance or what is the quantified value of that eigen a line. The eigenvectors give us the direction of that point or a line. So we can also calculate a dot product between two matrices. So finding the dot product is also takes a lot of time when we do manually. So that also we can do by using inbuilt function in a Numpy array. So for that, first we have to load the library. As usual, we have to correct two array. Array is nothing but a vector also. Here we are creating vector 1 and vector 2 by using np.array. After creating two arrays, have to find out the dot product between these two arrays. So to calculate dot product, we have a inbuilt function, that is np dot of, when we pass what are the two vectors we want dot product between them, vector 1 comma vector 2. This will give us the output as a dot product between vector 1 and vector 2. Alternatively, we can also find by just using this @ symbol, that is print of vector 1 at vector 2, if we do, we are going to get the dot products between these two vectors. So we can also generate random values using this Numpy library. How to do that? First we have to first we'll import the library, that is import numpy as np. After importing the library, I have to to generate a random values, the command what we have is np.random. So when you want any particular random values, like if you want an integer random value between a confined interval, like in this example I had 3 random integers between 1 and 10. So to do that, we have an inbuilt function, that is np.random will generate a random value. In the explicitly or particularly I want a integer random value, so np.random of rand int of I have to mention the interval. First will integrate the starting point, then the ending point, and how many number of values you want. So after passing all these parameters, I am going to get output 3 random integers between 1 and 10. Similar way, we can also generate a random values like a random numbers for a normal distribution. When we just have to give input as a mean and standard deviation. If we mention mean and standard deviation and how many number of random values if we want, you can get the normal distribution of random values by using np.random dot normal of the starting mean value, standard deviation, and how many number of random values you want. We can get that using this form command. So we can also do the inverse of a matrix, that is inverse of a matrix means any matrix whole power minus 1. So we can also do that manually, but it takes a time, as I told. So we can do easily by using just a single command, that is first we have to import library, then we have to create a matrix using np.array. After creating the matrix, we have to calculate inverse. To calculate the inverse of a matrix, we have to use command, that is print of np.linearalgebra.inv of matrix. So this command is going to give us the output as the inverse of a matrix. So we can also do like mathematical operation basics like adding, subtracting, multiplying matrices, or also we can find Fourier transform, sine of a function, cosine. We can do a lot of mathematical operation using this Numpy array. Here I shown only the basic things to do, adding, subtracting, and multiplying the two matrices. Like I told, adding and subtracting you can do manually, but matrix multiplication is a very tedious job. But that can also be done in a single line by using a single command in this Numpy library. So first we'll import the library. Let's first create two matrices. np.array of some 3 cross 3 matrix I have created as a matrix 1. One more matrix 2 I have created. After creating these two matrices, how to add these two matrices. It is very simple, just using np.addof by passing what are the two different matrices I have to add, matrix 1 comma matrix 2. If I pass the output, what I am going to get is the addition of these two matrices. So just np.addof, by passing the parameter I can get the addition of two matrices. So I guess in the similar way I can get the subtraction of two matrices, just np.subtract of matrix 1 comma matrix 2. So this command is going to give us the subtraction between two matrices. In the similar way we can perform the multiplication between two vectors. It is very simple, just by using star like symbol, print of matrix 1 star matrix 2. If I do, I am going to get the multiplication between two matrices. So those are the different types of operations we can perform using Numpy library, and there are still a lot of operation we can do. I showed only a few for you. So let's see what are the different applications of Numpy. As I told, Numpy mainly provides a high performance multi-dimensional array which we can use to store real-time values and do lot of mathematical operation and data manipulation techniques. So it is like, as I told, it is an alternative for lists and arrays in a Python, because these are very older version which we cannot manipulate data and we cannot perform a lot of real values, and we cannot do simultaneous calculation using those data structure. So n-dimensional array that is provided by Numpy will do those job very easily. So as I told, it takes very minimal memory. So when we want a less memory, when we have less memory, we can also do using this Numpy calculation. So while doing machine learning applications or doing any project, before in the data pre-processing techniques, or in using data handling techniques, in those also we are using Numpy only. And also we can do shape manipulation operations using Numpy, and various different types of mathematical operations we can do. And this application like Numpy can be used with other libraries like pandas, scipy, matplotlib, tkinter. We are going to use this Numpy library along with these libraries also. So thank you for watching the video. Thank you.